Good afternoon. I apologize for not being there. Something came up. So we are going to have to go over the first part of section 3.1 in your book. Okay. Our learning objective today is I will be able to analyze, graph, and write quadratic functions. So quadratic functions is something that you've been working on since Algebra 1. Okay, you will have this 3-question practice sheet due at the end of the hour. It is completely up to you on if you would like to work on it as you're watching the video. So you can pause the video, do the problem, and then come back. Or if you want to do it all at the end, but it is due at the end of the day. So first thing is, we are going to start talking about polynomial functions. So a polynomial function of degree n in the variable x is a function defined by a sub n x to the n, a sub n minus 1, x to the n minus 1, so on and so forth until you get a sub 0, which would mean that it's a constant and has no variable associated with it. Okay. You have been working on polynomial functions. These are our linears. Linear are polynomial functions. They are x to the first, so that would be, our n would be 1. We have talked about quadratics before. Okay, that would be x to the second power. That would mean your first term would be x to the second. Okay, we are going to talk about cubics a little more, so x cubed. Okay. Then we have quartic, which would be x to the fourth, and quintic, and so on and so forth. What doesn't fall under here would be square roots would not fall under here. Anything where you have a root sign, those are not polynomials. Okay. You have your rationals, which is when x is in the denominator of a fraction. That is not a polynomial. Okay, but any of these are polynomials. So the first thing is when we put it in standard form, meaning we go from the highest degree all the way down and we put it in numeric order. Okay, a to the n, the first term is called the leading coefficient. Okay, so for example, if I have f of x equals 3x squared minus 4x plus 2, okay, the 3 would be what we call our leading coefficient. Okay, this whole thing is what we call our denominating term. It's our first term. Okay, the last term without any variable, this is called our constant. The constant has no variable at all. Okay, it stays constant. It stays 2 the whole time. And then your constant would always be the y-intercept of your graph. So for example, in this one, my y-intercept would be, so if I was looking at this piece here, okay, in this example over here, my y-intercept would be 0, 2. Okay, because if I replace all these x's with zeros, this is going to go away, it's going to be 0. This is going to go away, it's going to be 0. So you're left with 2. Okay? Any polynomial function, this last term, this constant, will always be your y-intercept. So your y-intercept of a polynomial will always be the constant term, 0 to whatever the constant is. That's going to be your y-intercept. Okay? So today we are talking about specifically our quadratic functions. So our quadratic functions, remember, that would be, a quadratic would be anything, any polynomial with a degree of 2. So the highest exponent, the highest power is going to be 2. These will always make your parabolas. Okay, and let's go review a little bit of a parabola from Algebra 1. So remember, a parabola is always a U-shaped graph. So any U-shaped graph is going to be a parabola. Okay, there are two things that are well, there's more than two, but two main things that we are going to work on. Okay, our vertex is our highest or lowest point in our parabola. Our vertex always falls on a line called the axis of symmetry. the line that cuts our parabola in half, okay? And then we also have our x-intercepts and we have our y-intercept. So every parabola, I shouldn't say every, because there's certain cases. Parabolas will have vertex. It will always have a vertex. It will always have an axis of symmetry or a line of symmetry where you fold it in half. Okay? It will have sometimes x-intercepts. Remember our x-intercepts? There's three other names for those. Those are our roots, our solutions, our x-intercepts, and our zeros. So any of those words, that would be your x-intercepts. You do not always have to have an x-intercept. Remember, if we use the quadratic formula and we get i's, then we don't have any x-intercepts and a y-intercept. Okay, right now we will always have a y-intercept somewhere. You'll always have an axis of symmetry. You'll always have a vertex. The only thing that you might not always have is x-intercepts. Your x-intercepts, sometimes you don't have them. For example, if you have a parabola that would be opening up here, that would not have x-intercepts because it would never touch the x-intercepts. You would have imaginary x-intercepts. Okay, we go back to that I stuff that we learned first chapter. Okay, there are three types of forms that you will see quadratic functions in. And certain forms are good for certain things. We have our standard form. That would be f of x equals ax squared plus bx plus c. Okay, our standard form. Those make finding the y-intercept is easy. Okay, you really can find the y-intercept very easy. Your y-intercept is at 0, c. Okay, there's other things you know about that, but that's the really easy one, the easy one you can see. Now, we also have what we call our intercept form. This is when we factor. So if we take our standard form and we factor, that's going to get us our intercept form. So our intercept form would be f of x equals a times x plus b times x plus c plus, let's not do c, d. Okay, and this is called our intercept form because you have now found your x-intercepts. Okay, these are called your x-intercepts. That would be at negative b comma 0 and negative d comma 0. Hence why it's called intercept form. Now, if I want to go the other way, I just would multiply it. I would make a box and distribute the a, and that would get me this form. Okay? Our last form, and please make note of this because this is weird. Your book calls this standard form. Don't ask why, I don't really know. This is what you learned as standard form in Algebra 1. Okay, you have seen these two forms before. This form is the form that we're looking at right now. So this is our vertex form, f of x equals a times x minus h squared plus k, sorry, that's not a k, this is a k, plus k, okay? H comma k is your vertex. This is our transformation form that we just got done doing, okay? Now, if I want to go from standard form to vertex form, we have to go back to chapter 1 and talk about that idea of completing the square again. Okay, so in chapter 1, we had to do something called completing the square. Here it pops up again, okay, because that allows us to make this set of parentheses that allows me to create this little squared set of parentheses. Okay, once again, they have their goods and their bads. Standard form, really easy to find your y-intercept if that is what you need. Intercept form, find your x-intercepts, really easy if that's what you're looking for. Your vertex is very easy to find in vertex form if that is what you're looking for. Okay, remember you need 3 points of a parabola in order to graph it. Okay, you can't do it with 2, you can't do it with 1, you have to do it with 3. So here we go. Our first problem says write the following in vertex form, then graph using your graphing calculator. So when I want to go to vertex form, that means I have to complete the square. Haven't done it in a while. It was from chapter 1. Okay, if you need to go back in your notes, it's from chapter 1. So here is how we are going to complete the square. We're going to group these two things together and focus this is where the completing the square is going to come. The 17 is going to go for a ride. So first thing I'm going to do is I'm going to pull out a GCF. So the greatest thing I can pull out is 3. That leaves me with x squared minus 4x. Here is where completing the square comes in. We want to make this a perfect square. Okay, so we're going to find a number that makes this into a perfect square. So plus 17. Now, here's something different from chapter 1 because our equal sign is here. In chapter 1, when we added on the left, we added on the right. Sorry, when we added on the right, we added on the left. But because this is on the right-hand side, I need to subtract from the right-hand side to keep it balanced. Okay, so if you are a person that still needs the box, so here's my box. Okay, x squared goes in that part. I need to split negative 4 into perfect squares. So I put negative 2 here and negative 2 here. Okay, that would make this missing piece here would be negative 2 and negative 2, which is positive 4. So a positive 4 goes in here. Now, this is a little more complicated because of this 3 out front. So we have to put these two things together. So to find this number here, we have to do 3 times 4. This number times that number, and that gets me my 12 here. Okay, now I'm going to rewrite it. So 3 times, remember, this is the base of my rectangle or my square. So x minus 2 squared. 17 minus 12 is plus 5. So f of x equals 3x squared. So my final answer, f of x equals 3 times x minus 2 squared plus 5. Okay, now I know that I move right 2, 1, 2, and up 5. 1, 2, 3, 4, 5. And there's my new locator point or my vertex. So my vertex moves right 2 and up 5, and now I'm at 2, 5. Remember, this is my stretch. So I'm stretching by 3, which means I'm going to go up 3, 1 to the right from this point. So 1, 2, 3, 1 to the right. And then because it's a U, I have to go the opposite way. So 1, 2, 3 up to the left. And now I have my parabola. Make sure you make it a U, not a V, because it's a U, not a V. Okay? If you are a person that's going to go and stop and do their practice, go ahead and do your practice. Okay, next one says determine the x-intercepts and the vertex. So your x-intercepts, you factor. Your vertex, you complete the square. Okay, so I'm going to factor this. I'm going to pull a negative 1 out so it makes it easier. So x squared plus 2x minus 8. I'm going to make my diamond. So negative 8 on top, 2 on the bottom. So two numbers that multiply to be negative 8 and add to be positive 2 are 4 and 2. Okay, I don't have to divide in this case, so it becomes negative 1 times x plus 4 times x minus 2. Okay, therefore my x-intercepts are negative 4 and positive 2. So negative 4, positive 2. There are my x-intercepts. Okay.